All right, hello everyone. So today we're going to look at a couple functions for which we need to find the derivative, but it helps out to do some algebra beforehand. So I'm going to start with 21 here, and I'm going to start first of all by rewriting the denominator, the ln of the fifth root of x to the 6 plus 5, as x to the 6 plus 5 to the 1/5, okay? And with that being said, we can use this rule about logs, which is called the power rule. It says if you take the log of an exponent, the exponent can come down in front. So in our case, the 2 that's on as the exponent on the numerator can come down in front, as well as the 1/5, and that's the result you see right here. And I am going to start taking a derivative at this point right now, okay? Now, there is a couple more things that we could possibly do to simplify this. However, in particular, factoring some stuff from here and using another rule of logs, but then at that point it's a hindrance to the operation that I need to find. It's like, what I'm trying to say is, like, I did enough algebra for me to proceed with my calculus here, okay? That power rule was fairly easy to make, and I think I can take a derivative from it comfortably. So I'm going to take the derivative using the quotient rule. So I'm going to start by taking the derivative of the top function, and there I have to use the chain rule. The 2 would stay. The derivative of ln 3x to the 9th plus 7x squared, that's a chain rule. So you would, by the chain rule, we would have 3x plus 9 plus 7x squared on the top times, and then its derivative of the inside on the numerator, this would be 27x to the 8th plus 14x times 1/5 ln x to the 6 plus 5. And let me apologize for my small print here, but I'm trying to fit all this in. Okay, so the bottom times the derivative of the top, or whatever, the derivative of the top times the bottom. Now I'm going to go ahead and take the derivative of the top, the derivative of the bottom, which would be 1/5 times, again, another chain rule, x to the 6 plus 5, 6x to the 5th on the numerator, times the top function. So again, just quotient rule that we're applying to ln 3x to the 9th plus 7x squared, okay, and all over the denominator squared. And that's it. I'm not worried about simplifying this at all. It stays as is. Okay. So that's one example. Let me go to the next one, which is, I believe, number 22, that same worksheet. And we have the ln of the quantity ex to the 5th times x cubed plus 2 to the 8th, x squared plus 4x plus 4. Now, if you can notice this, that's great. If you didn't, that's fine. But x squared plus 4x plus 4 it's a okay factorization. It's x plus 2 squared. And again, here I can use rules of logarithms to simplify. And let me write out a couple more rules here besides the power rule. We have the first rule that you see there. That's the quotient rule, which says if you take the log, the difference between two logs, it's equal to the log of a quotient. The second rule, the product rule, the log, the sum of two logs with the same base equals the log of the products of the arguments. And then last but not least, the power rule. So I'm going to go ahead and use these rules here. These rules can be used in either direction. So first of all, I'm going to write the natural log of that quotient as a difference. Okay, let's go down here. So that is what you see here. I wrote this out as a difference. And then I'm going to use the product rule next to write this out as the sum of two logs. And the next thing I'm going to do is I'm going to take the power rule. The x to the 5th would come down in front. The 8 comes down in front here. And the 2 comes down in front. And last but not least, ln of e itself is just 1. So I'm going to replace it with just 1. So you get x to the 5th plus 8 ln x cubed plus 2 minus 2 ln x plus 2. And that right there is just the function itself. It's not the derivative. We have done no calculus, but I will do some calculus at this point. Yeah, and this was a more complicated function in itself, so I was able, it makes sense that we could apply more of the log rules here. And also some of the simplifications were like okay to do, in the sense that weren't that hard. So that's why I did all these like steps to simplify this expression. Okay, so then I'm going to go ahead and take my derivative now. The derivative of 5x to the fifth would be 5x to the fourth. The derivative of 8 ln x cubed plus 2, that's a chain rule, be 8. Then on the bottom, x cubed plus 2. Then on the top, 3x squared. And the same thing, chain rule for the last one, 2 ln x plus 2. The 2 goes in front, x plus 2 on the bottom. The derivative of x plus 2 is just 1. That goes on top there. And that's it. That is your derivative. If we had not used these rules, this would have been a much harder problem to work with. We would have had to start off with, well, first of all, it's a whole chain rule here. And then you would have had to done a quotient rule and a product rule. It would be really long. So again, the point being is algebra before calculus. Do some algebra if you can, if it's not too much, too difficult to simplify your expression. And yeah, we had an ln of a quotient and some ln of a products, and then we had some powers we put in front, and that was okay. And then we took the derivative from there, okay? All right, well, thank you for your time.